Welcome everyone. I'm Thomas Neeson. I'm really pleased to invite you to this, the third of our webinars on our sustainability series, as we look to what we can do in the world to make things better. Today's session is entitled "Is Offsite Construction the Future for the Built Environment?" Gordon's going to take us through that. I hope the answer is yes, or it might be a very short presentation. But yeah, we'll get into the meat of that in a minute. So we meet in very challenging times during the middle of this COVID crisis. But the thing to remember is that this will be I know it seems a long-term issue at the moment, but it will be a short-term issue. We will come through it, we'll come back out of the other side of it, we'll go back to work to do what we're all paid to do, work on the built environment, developing buildings of the future. And it may well be seen as a real changing point in how we think about the way we work, what the buildings we use are, what the important ones are, who the important key workers are. So it could be quite a transformation for the whole industry of the built environment that we work in. And today's topic will be part of all of that. Will offsite manufacture actually be a good thing? Will it help to reduce the amount of interaction on site, for example? Will it help to reduce delivery times? Will it help to add to prefabrication? Will it help to design standardization? Quick deployment like the Nightingale Hospital? There's going to be lots and lots of lessons that we will learn through this process. Sustainability is the heart of everything we do at Cundall. Gordon will take you through some of that as well. We have 4 cornerstones, and this just adds to part of what we published in our sustainability roadmap. How do we influence our homes and communities, our workspaces that we work in, the projects we work on, and then lead industry so that we can all deliver better in the future. The seminar will be about 30 minutes long. Gordon's got about 1,000 slides to present in that time, so we'll be rattling through that quickly. Then we'll have a Q&A session, but ask your questions as we go along. There's a Q&A facility on the webinar. Give us your ideas. We're all here to learn. You can teach us stuff. We hope we can teach you something. So chip in with that, and if we don't get through all the queries, we'll answer them by email afterwards. Today's speaker is Gordon Reid. Gordon's a partner based in his kitchen at the moment, and normally in our Newcastle office. He's got lots and lots of experience. He's got a real passion in both structural engineering, but more importantly in developing the engineers of the future. Spends a lot of time mentoring, leading courses, teaching people as to how to become structural engineers with a sense of humor, which is very important for a structural engineer. Works hard on that, and get some of that will come through on the presentation today. So I won't keep you any longer. Gordon will take us through the current direction of travel, some of the developments we're seeing, some of the learning that we have done, and some of the things that we can bring to bear on our project. So without any further delay, take it away, Gordon.
Okay, thanks very much, Thomas, and thanks everyone for joining. I'm just going to share my screen and we'll get started on the presentation. So hopefully everyone can see that now. Is offsite construction the future for the built environment? Thomas said it's a yes or no. I'm not quite sure it's that simple. I think, in my opinion, it's a yes, but, and you'll see why as we run through it. So a little bit about Cundall first. We'll give you the hard sell and tell you a little bit more about ourselves. We started in 1976. We now got 21 offices globally and 950 people. Most of the 950 are actually working at home, so you could argue we've got 950 offices. We're a One Planet Living accredited company. We're the first consultancy to achieve that, and we're very proud of it. As Thomas says, sustainability is right at the heart of what we stand for and what we do. We've got offices around the globe. The dark blue indicates where we have offices. The light blue is other locations where we have projects. Again, Thomas mentioned the cornerstones. So how can we be seen to be providing industry leadership? How can we influence sustainability on our projects, in our own workplace, and in our homes and communities? So we've set ourselves targets for each of these, and as Thomas mentioned, the sustainability roadmap communicates what our targets are. Have a look on our website, and also we publish a report which tells everyone how we're doing. What do we do? Our core services are sustainability, mechanical, electrical engineering, structural and civil engineering, but we also offer a host of specialist services, most of the services you would expect on a building development infrastructure type project. So you can see some of them there: fire, acoustics, geotech, planning, etc. We work across all of the sectors you might expect. That's quite a deliberate choice of ours. We want to make sure that we've got the diversity of work and it helps sustain our business. So getting onto the presentation, I'm going to take you through the offsite agenda, some of the drivers for change, give you some examples of the type of thing that might be available to you. You can consider some of the pros and cons. I'll talk you through some examples of projects that I particularly like, or projects that we've worked on as a business, and also give you an MEP perspective about some of the things that are happening regarding offsite fabrication. And at the end, a little bit about what next, what do we think is going to happen soon. So offsite construction, quite a lengthy definition there. It basically means making something in a different location to the location where you're actually going to use it. And starting with this, really, I think offsite construction, there's still a bit of stigma about it, that it's boring, it's got to be rectilinear, it's not very nice. And this sort of image sort of sums up some of the preconceptions, and I'd really like to take you through examples that hopefully will take you away from that. Over the years, architects have experimented with offsite construction and modular construction in its various forms. And two really good examples there. They are really Marmite examples. You either love these or you don't. And opinion has been quite divided about it. But now I think we're starting to move on really and really exploit the full potential of offsite manufacture. So a little bit about the drivers, some of the things that are starting to influence why there is a trend towards more offsite manufacture. About 5 years ago, the Pharma report was issued. It was very, very critical of our industry and its underperformance. In particular, it was looking at the fragmentation that exists, the lack of collaboration, the low productivity, and the lack of a feedback loop, that we weren't learning from mistakes that we made in the past. We weren't sharing good ideas and passing them on to the next project or incorporating them. We were going back to start again far too often, and all the negatives associated with that. The government latched onto this and thought, well, okay, we need to really think about this. What is this person telling us? What else can we do? And they came up with some key headings in terms of things we need to do better moving forward. And in particular, it was smart construction, sustainable construction, and improved productivity. And these were translated into targets, and the targets were set for 2025. And they're very, very tough targets, to be perfectly honest. How can we lower costs by 33%? And we're talking about whole life costs. How can we deliver projects from inception to completion in 50% of the time? How can we reduce emissions by 50%? And how can we do all these things and actually start to export more from the UK as a result, and have the UK sending building products, materials, systems elsewhere? Here we are in 2020, and do I think we're going to hit these targets? And I would say probably not. I do think, though, that they are aspirational and they are certainly pointing us in the right direction. And there have been some major steps forward, but I'd be surprised in 2025 if we hit these targets. I'm going to take you now through some of the types of offsite construction, and perhaps I've got my structural engineering hat on here. These are the things that I'm most commonly getting involved in, and I'm also going to touch a little bit upon the MEP issues that we can address, and some of them that we are actually addressing already. So if we go through volumetric, I think everybody knows what that is. You're manufacturing a space, a room. Cross-laminated timber is becoming increasingly popular. Again, very sustainable, low embodied energy. Structural framing systems using light gauge steel. Again, modest quantities of steel for the structures you can develop. Brick slips, I'm going to take you through some examples of those and how they can be utilized. Looking at precast, timber frame, structurally insulated panels, and then going on to riser distribution routes and plant rooms. So I think it's important that we start off thinking about okay, we would quite like to incorporate some offsite technology into our scheme, but how are we going to do it? And I think the key point there is you need to think about it really early. You need to think about whether it's appropriate for your scheme. You need to think about how it could influence the design of your scheme, and how can you integrate it with the on-site materials that undoubtedly you will also need at some point in the scheme. And guess what I'm pointing towards here is collaboration. You need to start to speak to the offsite manufacturers. You need to start to pick their brains. You need to understand the limitations and appropriateness of their products. And you need to feed that right back into your concept design. If you go too far down the line and then think, right, I would quite like to incorporate some modular offsite technology here, you will often try to implement that in the wrong way, and you'll try to stretch the manufacturer in a direction that is not best suited to their particular product. So you do need to change that thinking around and start to think about it early, and how might I do it right at the very start. It's not an activity you can integrate halfway through the process. You need to think about the logistics of it. Does it work? Can you get the materials to the site? Can the manufacturer supply the quantities that you particularly want? Is there security of supply that you need for a program that could be critical? You also need to start thinking about, okay, we've finished the job. What about maintenance? Where do I get the spare parts? How do I get back in and maintain this? Who knows how to do it? So again, these factors, they're shown as a chain of events, but they need to be thought about at the concept stage. So thinking about the program in a little bit more detail, at the top, we've got a fairly traditional on-site program where you complete your design and then the client will make a commitment to construct. The construction starts, and while the construction's ongoing, the design sort of continues in the background, and the later phases and later packages of work are still being designed as the early stages are being constructed. That's quite normal. It's probably what we're all used to. If you're thinking about offsite, there's a different emphasis altogether. You need to commit to your design before you start building. You need to sign that design off in order that the work in the factory can actually commence. So there's a different mindset required. The client needs to be more confident that he or she knows what they want. We need to make sure that as designers that we give those options to the client. So there is more of a cut-off date, more of a commitment at the contract award stage. The benefits usually are in terms of time. So if you look at the diagram on the bottom there, you'll see that there is a time saving at the end, and that generates a return on investment for the client. So offsite versus onsite, some of the benefits here, I won't go through them all. If you got your rosy tinted spectacles on, you could take all of these benefits and say they're all entirely appropriate and they will apply. I don't think that's necessarily true, but they will apply to the majority of projects, and there'll be some that you can tick off the list and say, yes, it is appropriate. So more reliable delivery, I think that one would be a given. Efficiency and optimization, going back to the idea of the feedback loop, I do think that is a really important consideration in the offsite world. You make a mistake, you put it right, and you make the next product slightly better. Quality, factory control conditions, easier to check and verify the work in the factory than it is on a site. Safety's got to be a key consideration as well in terms of eliminating the need for temporary works. And environmental impact, I'll come on to later and give you some examples of the benefits you can achieve there as well. The key one is probably the last one there in terms of increased productivity. Again, the government in the UK are pushing the industry towards that, and this is a great route to pursue. We can build things more quickly. Productivity is typically measured in terms of pounds of output per employee in the industry, and our figures are particularly poor. I'm based in the northeast, and our figures are even poorer than the southeast, which suggests that people are embracing this technology in a market that is probably a little bit busier, a little bit hotter. Wider economic benefits. Well, we can improve working practices, come back to skills and efficiency. We can boost the productivity. Construction sector GVA can increase as a result of that. We can build things faster. We can all move on to the next project a little bit quicker. And that will have an impact on the wider economy, especially for our clients as well, who can use the buildings more quickly. So looking at waste, offsite manufacture, we can reduce the waste to around about 1 to 2% of the material used on a typical construction site. At the moment, we're generally in the band of 5 to 10%, so quite a significant reduction in waste. The waste can be recycled and reused at the manufacturing facilities, and we should make less mistakes on site and accordingly generate less waste on construction sites. Moving on to sustainability, if we're smarter and we use materials more efficiently, we will use less, therefore less embodied energy. We can use materials that contain less embodied energy as well. Quality control, if we improve that, that should lead to less durability issues and less of a maintenance commitment for our clients. And we can optimize things, as I said before, being smarter. Some of the drawbacks, there are always drawbacks. Cost, sometimes the capital cost of offsite technology can be neutral or slightly more expensive. You can get payback, of course, in terms of faster use of your building, but cost is not always an obvious benefit. We've had examples before where lenders are refusing to provide finance for schemes where we're using offsite technology because they view it to be too new. Perhaps it's untested, they're unsure about the longevity of it. So there is a reticence that we need to overcome. It's a major design consideration. I've already explained that you need to commit to it early. So is that really appropriate? Are our clients able to do that? Do they want to do that? Subcontractor security, if you're placing a large order with one subcontractor, are you confident that that subcontractor is still going to be around? Especially true in the current climate where a lot of companies are struggling. Lead-in times, you need to factor that into your program. You need to work back to your sign-off date, and you need a very, very strict design freeze. Changes are expensive. This is a big, big issue. The key one there is the second from bottom, where systems work best within a defined range of parameters. That goes back to the collaboration and the integration that I talked about. You need to try and work with the manufacturer, not work against them. Try and work together and utilize the best facilities that their product can offer. Don't try and stretch the manufacturer in a whole new direction. You will not generate economies, you will generate delays. So here's some examples. This is one that I really like, Urban Splash. They've got a housing product, very, very simple. You buy an apartment or a house and it's 60 meters squared per floor plate. And the choice you have on this development, for example, was you could have 120 square meters, i.e. 2 floors, or you can have 180 meters, 3 floors. The customization comes in what happens inside. You can have your kitchen at the middle floor, at the ground floor. You can have your staircase back left. You can have it right in the center. You can divide it into cellular accommodation with lots of bedrooms. You can have it completely open plan. So they've taken a very simple concept of standardization. So the houses look fairly standard from the outside. Inside, it's like choosing a kitchen in a house. You choose your layout, utilizing the systems that they've got, and they will manufacture that in the factory for you, and your house will be to the layout that you require for your family. G-housing, this was a scheme that we worked on. It was a design competition looking at how perhaps we can address the housing crisis in the southeast and how can we get houses built more quickly. The answer that we came up was to use a reinforced concrete insulated sandwich panel, so 2 layers of concrete with the insulation in between, using trapezoidal modules that you link together to create the size of dwelling that you want. The precast concrete is clad, it's pre-finished, the roof is on, and again, the optimization that occurred in the design meant that we used the minimum amount of materials and the process was continually refined. I've got some photographs now that show you how it's manufactured. So the units are manufactured approximately 2.5 meters wide. They therefore fit on the back of an articulated vehicle. They're delivered to site, they're lifted into place, and you can have the bespoke features such as the timber cladding that we show on the bottom right in place and ready to go. But you can also play a few tunes with it. You can scale it up and to make something a little bit more different. You can have a fully glazed facade. You can reorientate the units to create some more interesting shapes. You can stack them to create 2 or 3 story dwellings. The photograph on the bottom was a traditional reinforced concrete podium with the units landed on top. So again, there are things you can do to try and make it unique, to make it more interesting, to make it more personal to the client's particular requirements. Parkview Student Village was a student residential project that we completed in 2018 in Newcastle. And the system we used there was to use shipping containers. The shipping containers were stacked. They provided the basic structure to the building. They were stacked 11 stories tall. And what we did, we clustered them around a traditional steelwork core. We initially started off looking at building the core out of modular components as well, and we soon realized that that was going against the grain of the manufacturer. It was proving quite difficult for them. They would have to change their manufacturing process, and as a result the price was going up. So our concept was to try and use a hybrid of traditional and offsite techniques. That generated a saving of about £2 million, helped the team we were working in to secure the project, and the traditional works could actually progress while the units were being manufactured. So taking you through the site, a very constrained site, so we had to think about the logistics of delivery, what we were going to do there. This is what we were looking to build, so 6 blocks in a cruciform arrangement. £68 million project, 1,277 beds, 104-week programme. It was a 2-stage tender process. That was really, really beneficial because during the first stage of the tender, we could integrate with the manufacturing company who were making the units. We could start to talk to the client about sign-off, talk to the client about the specific details of the design, and the 2-stage process worked really well. Looking at some of the key dates, what you'll see here is the contract of award was on the 18th of July, and the modules were actually ordered on the same day. So we were ready to go at the end of the first stage of the tender and ready to book a slot in the manufacturing facility. It didn't mean that we started the manufacturing straight away, but we wanted security of supply. We wanted 1,277 bedrooms, and that was a big ask, and we needed to make sure that the time slot was booked in the manufacturing facility. The manufacturers were based in China. You could argue that that wasn't particularly sustainable, and I'd be inclined to agree with that. But the sheer volume that were required, we couldn't find a UK supplier who could hit the program dates and guarantee that supply. If you look at the sign-off was made in November. We constructed a prototype and built it in a squash court in the northeast of England so the client could see exactly what they were getting, and the units were delivered in April. The overall program, we estimate that we saved between 6 and 9 months on compared to a traditional construction process. We actually clad the development in traditional bricks, which was a shame. We couldn't persuade the client on this one to use brick slips. They'd had a poor experience on a previous project, but I think we could have saved another 6 months if we'd actually gone down the offsite route for the cladding as well, but that was something the client chose not to pursue. So in terms of contract value, the cost per bedroom was about £53,000, and you can see that the largest proportion of the cost was actually the modules themselves. So again, going back to the point about contractor security, we needed someone who was financially stable, someone who could deliver 1,277 beds in the time that we had available. And it was a major concern for Galliford Try, who were the main contractors. So they did a lot of homework to make sure that we joined up with the right offsite partner. In terms of quality, it was really important that when you opened the door, and by the way, the units were all fully furnished, the bed was in place, the desks were in place, all the kitchens were installed, that the quality was of the standard that we required, that all of the colours were exactly the colours that the client expected to see. So we used the Oculus Rift, we put the goggles on, we did video walk rounds of the facilities in China before they were signed off. We used augmented reality to make sure that the client could visualize entirely what they were going to get, so there were no surprises. And our Hong Kong office called into the facilities in mainland China on a fortnightly basis to do quality control inspections, so that when the door was opened to the unit, everything was as expected. So there's a photograph of the units when they're all stacked in place. You can see the 11-story tower in the center with the units stacked on top, so that the units provided their own structure and they provided their own stability to the development. All the windows were pre-installed and all the units were fully furnished. As I mentioned, we decided on the Parkview project to use bricks. We would have preferred brick slips, so the same team moved on to another project in Leeds. This was for a private rented sector development. Much larger windows, the fenestration was different, but we did use brick slips there. So again, that had even more program benefits than the example I gave you on Parkview. So we took some of the lessons learned and we changed our design slightly for the next development we moved on to. Brick slips again, this is a development in London. It's another student residential development, and all of the brickwork that you see there, it's very ornate, lots of feature bands, lots of corbelling, etc. And this was all achieved using brick slips. A factory in Stoke constructed the slips for us. They're all cast into precast concrete backing panels, and then they were lifted in place. That meant there was no scaffolding externally. We didn't have a road closure to close the road for the duration of the development. We could only get intermittent closures during the evening. So these were lifted in during the evening, bolted into place, and then the road was open again during the day. So the reasons for it were due to accessibility. So the driver there was very different to Parkview. This is a development in Leeds where we built 7-story timber stud buildings. Again, one of the tallest buildings in the UK using timber stud. This is a development where we used a hybrid solution again with a reinforced concrete core with light gauge steel panels to form the development. We couldn't get the stability to work on the 13-story development using the light gauge alone, so we worked with the manufacturer to introduce a concrete core in the center and allowed them to fix the light gauge steel to it. The core extended 5 stories high, then the stability was provided exclusively by the light gauge steel above the 5th story. But by collaborating with them, we were able to integrate that product into the development, whereas initially 13-story was beyond the capability of their system for this particular layout. Moving on, just to show that it's not all about the residential sector, that people can use modules in different ways. This is a hospital constructed in 28 weeks. I'm sure you've all seen the hospitals that have been built, the Nightingale ones and the ones in Wuhan that have been even more quickly than that. This was using modular steel panel systems. Next one is a school development, the largest offsite school that's been built so far in the UK. This one was delivered 17 weeks early. Heathrow were very keen when they were looking at their runway development to use offsite manufacture, and their driver was quite different. They were very concerned about the number of people on site on a £14 billion project, and they'd calculated by manufacturing things off-site at off-site hubs, they would reduce the number of people on site by a factor of 5. Very important when security is a key issue, and getting people into the workplace and screened is essential. I've already talked about the Wuhan hospitals. I've got a link there at the video. I might play that at the end. I'm going to move now on to MEP and give you some examples about how building services engineers are incorporating off-site technology into their designs. Prefabricated plant rooms, very space efficient, very quick to build. I've been down to visit the Langerock facilities, and they are majoring on this. Very, very cost effective to deliver, especially when you consider the time savings. This is an example we've been working on recently in London, where we've prefabricated the risers. There are no concrete cores, no blockwork shells here. The risers themselves are generated by the framing here. And one of the key drivers here was to provide a riser that is very lightweight, very quick to build. One of the key activities that we've been carrying out is to witness the construction of these in the factory, accept them, sign them off, such that when they're delivered to site, we know that they are correct and ready to install. They were lowered in using cranes and dropped in through the roof, down through the building. So again, very, very quick. Prefabricated services distribution. More and more people are now building racks off-site, which are again lifted in position and fixed. Very simple, very easy to install. Slightly complicated if you have lots of falls in the drainage, etc., to make sure you get the tolerances right, but not an insurmountable challenge. We're all familiar, I think, with bathroom pods and bathrooms. We've seen that in a lot of developments for a number of years. If you go into the school sector now, a lot of schools there's a modern method of construction framework, which is becoming increasingly popular. The government are driving this and persuading more and more people to invest in these facilities such that it becomes more common in the workplace. And the services, a lot of them are plug and play, so you don't need as many skilled tradespeople on site to complete the development. Are we embracing it on the MEP side? I think the answer is a yes, but again, there's still a big gap, I think, between design and construction, and how do we manage the interface between designers and contractors and subcontractors? That gap is beginning to close. I think it's an issue still for some. It's great to see some of the examples that we've shown you where people are starting to embrace it and move on. I'm going to stray off topic now a little bit and tell you about a few things that we're looking at that could come next. We're working with Loughborough University at the moment and with some PhD students about 3D concrete printing. This is an example of just some large planters which are being printed using offsite technology. This is an example that I really love, where in Eindhoven, the university has made a pledge to print 3D houses by 2023. I don't think it's far away. They're on program. I think this will happen soon. One of my colleagues in Hong Kong, he's working with the School of Architecture there and looking at robotic bricklaying and how can we optimize that process, how can we make it safe, and how can we reduce construction time as a result. I'm working at the moment with Newcastle University, and they've got a £6 million grant to look at how biology can influence construction going forward rather than physics. And this is one of the projects that they're looking at. They're looking at growing bricks. So the idea is you fill a mold with sand and you gradually add water. The water is rich with bacteria. Over a period of days, that starts to form crystals similar to coral. And in about 5 days, you can grow a brick. At the moment, the preliminary tests that we've been doing on this suggest that the bricks have got properties very similar to sandstone. So it shouldn't be too far away where we can start to utilize these in construction projects, which would be very exciting. Very low energy, obviously. You don't have all of the heat you need in terms of energy to fire bricks. Something very similar, we're looking at mycelium, which you find in mushroom roots, and mixing it with things like wood mulch or corn husks. And again, allowing a chemical reaction to grow a product that we can use in our industry. So there's some examples here where it's been used in sculptural forms. We're now looking at how can we incorporate these into building developments. Newcastle University are building a prototype on site at Newcastle at the moment, and they call it Home without the H, and they are looking to clad it using some of these materials and see how they stand the test of time and see what lessons we can learn. But again, very exciting, and I don't think it's too far away. Bioenergy facades. We're looking at algae and how we can incorporate algae within glazing. Algae will offer thermal shading to the building. But also if we feed the algae using waste carbon from other combustion technology, perhaps within the building or adjacent buildings, we can use it as a fuel cell. So we can generate electricity as well as providing thermal shading. So there's some major topics under consideration at the moment, and I don't think they're too far away. I do think we'll see some enormous changes due to the drivers being introduced by government and also by the research that is happening. And I think in 5 or 10 years' time, we will be doing things very differently. So to go back to the question that Thomas raised at the start, is it the future? I think it's yes, and I think the but is a small but. So that's the talk for today. I hope you've enjoyed that and found it informative. We'll move on to questions in a moment, but I'd just like to flag to you that we've got some more coming along in this series. My colleague Mike Gosling will be talking about co-working in a week's time. Then we'll be moving on to overheating in residential properties and how can we manage that better. And we'll be looking at lighting in office space and how that impacts on health and well-being. And Andrew Bissell will be covering that on the 13th of May. So if you enjoyed today's presentation and you'd like to find out more about these topics, please sign up. In a short while, we'll also be hosting a panel discussion about designing in the post-COVID era. How will that change what we do? How will that influence construction in the next year or 2 years? Thomas also talked earlier about social distancing. Perhaps offsite has got a role to play here, that we manufacture more things in the factory and we bring them to site rather than having lots and lots of people working together in a confined environment. But please join us. There will be an invite coming along shortly for that one, so please look out for it if that's a topic of interest to you. So thanks everyone for listening. I think I'll hand back to my colleague Natalie now.
Thanks, Gordon. We've got a couple of questions that come in. So the first one is, should clients prepare scheme design to include offsite production? Why should it be left to the main contractor? Seems like there's lots of wasted effort.
Yeah, I would agree with that. I think clients need to be alive to that, and I think it's part of our job as consultants to present them with the opportunities that are out there, things that they can consider. It shouldn't just fall on the contractor to be the people who are leading this. I think there's a role across our industry, and I think that's really what the government in the UK were driving at, that we are too fragmented. And why should one party rather than another take the lead? There needs to be a collaborative effort. So I would agree with that. I think there is a role for clients and there's a big role for designers and contractors too.
Okay, thank you. Another question. Offsite construction solutions are often of lightweight construction methods resulting in low thermal mass. How do you make sure that this approach doesn't result in overheating issues, particularly for domestic applications?
Yeah, I think that's true. But again, I think it would come down to the way that you choose to insulate your building. You know, if you look at a lot of passive house developments, for example, not all passive house developments rely exclusively on thermal mass. There are passive house developments that are there that are very lightweight solutions. So I do understand the point, but I don't think it means it's a no to offsite and lightweight technology.
And there are some, not all lightweight offsite construction methods. I mean, you went through one of them, didn't you, Gordon? The residential system that we had worked on. Well, we've also, there's lots of people that are doing precast offsite solutions for site assembly. So possible to come up with systems that can incorporate elements of mass if that's what we want to do in our buildings. Yeah.
Okay, thank you. And the final question that I've got so far is, there's two actually. Do you think that the current COVID situation will increase clients' interest in offsite pre-finished solutions? And the second question, will the requirements of PI insurance and risk be a barrier to innovation?
Yeah, on the first one, I think undoubtedly the COVID situation will make people think differently across a number of industries, including construction. Obviously, if you're working in a factory environment with a lot of machines doing the work, there are less people and less people who need to be in the same space. If you're using offsite to generate products and materials that are lightweight, for example, things like two-man lifts are significantly reduced and helps with social distancing. So I do think that COVID will force people to think differently, and more focus will occur on the offsite side of things. So yeah, I agree with that too. Moving on to the question about PI and will it restrict innovation? I think we're already seeing that, to be honest, which I think is a real shame. I can think of a number of situations where we have tried to champion something that is a little bit different, only to generate a little bit of nervousness. So I think people like the BRE and Agrimont certification for products is really important. If you take the research activities that we talked about at the end, that's really the role that I'm playing at Newcastle University. I'm not an expert in microbial science. I'm trying to influence the university about what they need to do in terms of certifications, such that people in the industry will be encouraged to use that product, and they'll have the confidence to utilize it. So perhaps the role that's a role that we can all take up. We all know what we expect from a product, what we want from a product, what sort of parameters are key, what scrutiny will be put upon it, and that's the interface that I'm providing to the research project at Newcastle University. But I do think there is a nervousness about being innovative, which is a great shame.
But it's not just PI insurance, it's buildings insurance as well. We know lots of clients who would love to do more with timber, and they're saying the insurance market is just not open to it at all. So they're saying, look, they're looking around, they're looking at a timber solution, and they can't get insurance from their buildings insurers to insure it. And even if they can get insurance for it, their insurers are coming back and saying, right, okay, how many other buildings are within a certain radius of it in your portfolio, and then increasing the insurance on those. So it's quite a difficult, timber is a really big missed opportunity, I think. I mean, it's been more grasped now, but the French government, for example, have come out to say that they want 50% of all public buildings to have timber structure in the future. That's going to be a big change in industry. And if you've got the insurance industry, for example, pushing hard back against that, then obviously that's a blocker to it. So there's obviously, as Gordon says, research to be done, people to understand it. There's timber buildings that have stood for hundreds of years. There's a very nice one in the quayside, Newcastle, that's been there from 1300 and something in the cooperage. So they can work, and they can work for a long time. But yeah, we need more research, understanding, and everything to make it really move forward.
Just to follow up on that point, on the timber side, there's a lot of nervousness about fire in the temporary works condition with timber, and I would say that's the area where the insurers are most concerned. But there are published guidelines now in terms of the plans that you put in place to minimise that risk. The development we showed you there at the University of Leeds, that was one of their concerns about vandalism, people setting fire to the development. How could they manage that risk? And there are published guidelines that you can utilize to make sure. In the final case, I'm very confident about the behavior of timber in fire, and we can satisfy insurers in that regard. There is more a question mark on the temporary state and how we look after it during the construction process. But again, that is manageable.
Yeah, we've got a couple more questions that have come in that are kind of both, I think, saying the same thing. The first one is touching on what you said earlier, Gordon. It's disappointing that modules are being manufactured in China. Urban Splash is a Japanese company, but for me, this is a big barrier. And another one's just come through there to say, what's the general capacity of prefabrication manufacturers in the UK? Is there any major blocker to prevent this becoming more homegrown?
I think that there is a lack of capacity in the UK. I think there's some excellent products and some excellent companies available to us who are doing some really, really good things, and I'd love to see more. The government, I think, are trying to make sure that there are more by, as I mentioned before, the EFA have come up with a modern methods of construction framework. So what they're doing is they're guaranteeing a pipeline of work. If they guarantee a pipeline of work, that will encourage more and more people to participate in this and make the investment in their production facilities. So the government are on side with this, and I think that will be the catalyst that will drive us towards more of this. At the moment, it's quite speculative, where people have got to decide that they want to do it and they can see the market, whereas I think the government are now trying to make sure that the market is there and try and improve the market prospects.
And I think it's the nature of bespoken in this country as well. Just going through this talk, I mean, you're saying there, somebody's raised the point, there's capacity in Japan and in China for this. A large modular provider in the UK may provide, I don't know, 500 units or 1,000 units a year. There's Japanese suppliers that are available to provide 50,000 units a year, not 500. And a lot of that comes out with, you know, a bit of design standardization. I mean, we could get into a chat for the rest of the day with, you know, architects and other designers about how that may or may not work. Quite a lot of this modular offsite construction was used at Canary Wharf 30 years ago, and down there there was a rule book for design, and everybody had to stick to it. So we couldn't just, you know, tweak things, shave a few mil off here, save a bit there. It had to be fairly loose fit, and it was fast and went up really quickly because everybody had to work to the same set of rules. And I think we'll need probably more standardization will facilitate a lot more modular construction, less waste, higher speed, more guaranteed cost. But that's obviously quite an interesting debate to have to mix that against design and freedom to design.
Yep. I think that's us. We're out of time for this morning. There are a couple of questions that have come through about modular roofs becoming more popular, and also how we look at sustainability and using timber. So what we'll do is we'll provide an answer to them and email them through, just so that we haven't missed anything. But just
I saw that, and some of the sustainability element of timber and materials would have been covered in Reid's presentation.
Yeah.
So we can direct people towards
We'll
those.
share a link to that one. Yeah, absolutely. So thank you, Gordon and Thomas, for this morning, and thank you to those who joined us. If you've got any further questions, just ping a note through and we'll get them answered for you.